Hello, my dear children of class 11 science. Yes, now we'll start a chapter and the unit, the last unit as per the class 11 syllabus, and the unit that we are going to start is unit number 10, the important unit also, and the unit name is oscillation and waves. So in this unit there are a number of chapters, okay, but we do only the important chapters. And one of the first chapter that we need to discuss in detail is called simple harmonic motion. So children, we start with this chapter. So one of the important chapter, not important only for your examination, for even for your what? Important, equally important for your competitive exams also. And the chapter name is simple harmonic motion. Okay. Now to start with this chapter, let me just start with the concept of motion and its time. You know, motion means something which can change the position. The body will change the position with respect to the immediate surrounding. If a body changes its position with respect to immediate surrounding, then we say that the body is in the state of what? Motion. But you know, motion are different types. Motion are what? Different types. So out of many types of motion, so we start with one of the motion that is called periodic motion. Yes, children, you have learned this type of motion in lower class also. Periodic motion. Now what is periodic motion? The periodic motion basically means a motion that is acquired by a body. When a body repeats its motion continuously, the body repeats its motion continuously on a definite path in a definite interval of time. So when a body repeats its motion continuously on a definite path in a definite interval of time, then such type of motion is called periodic motion. So as for the statement which I have made just now, so the same statement can be written in the form of a written way also, that is that a body repeats its motion. Means when a body repeats its motion continuously on a definite path in a definite interval of time, then that motion is called periodic motion. And the time interval which is required for to have periodic motion is called time period. So children, time interval which is required is called time period. So I just want to add time interval required is called interval. Okay, time interval required is simply called as what period? Time period. Now there are a number of examples of what? Periodic motion. Now Earth, you know, complete one revolution around the sun in how many years? 1 year. Now this motion of the Earth is a what motion? Periodic motion. Because the time period which is taken by the Earth to have one complete revolution is called 1 year. But this is an example of what motion? Periodic motion. Because the motion acquired by the Earth repeat continuously in a definite path. The path will not change. And even this repetition of motion occur in a certain definite interval of time. That's why the motion of Earth, I mean the revolution of Earth around the sun, okay, is also one of the example of what? Periodic motion. Other than this, you can see another example like helicomets. You know helicomets. Okay, the helicomets always orbit around the sun. Okay, and helicomets around the sun is after every what? 76 years. That means this is also the example of periodic motion. And this 76 years is the time period which is required for helicomet to just round the what? Sun. The moon, as you know, another example, complete one revolution around the earth. And you know how much it takes? Almost 27.3 days. So moon takes almost a time of how much? 27.3 days to complete round the earth. So that the motion of the moon is also taken as the example of periodic motion. And this time which is required, 27.3 days, is a what? Time period. Okay. Similarly, the motion of the hands of a clock is also the example of periodic motion. And the time period of one hand, 1 minute and 1 hour, and that of what? Hour's hand is 12 hours. That means this is also the example of what? Periodic motion. Okay, now you know that when the hands of the clock revolve, okay, usually what happens? The time which is required to have one revolution is required for by the number of seconds. Okay, I mean to say, in 1 minute there is 60 seconds. Okay, in 1 hour there is how much? 60 minutes. But when the clock of the motion of the hand of the clock are in a steady motion, then this motion of the hand of the clock also acquire what motion? Periodic motion. Okay, so these are the common example of what motion? Periodic motion. Now we have another type of motion which is related to periodic motion. It's called oscillatory motion. Now you have learned, children, in lower class also what is oscillatory motion. And oscillatory motion simply state that if a body in periodic motion, see, a body in what motion? Periodic motion, moves to and fro about a definite point, and we call this definite point as mean position, also called equilibrium position, then the body is said to be in what motion? Oscillatory or vibratory motion. So this is the statement of vibratory or oscillatory motion. So that means oscillatory or vibratory motion is also considered as a periodic motion. But under what condition? When a body have to and fro motion about a definite point, and this definite point is called mean position, also called equilibrium position. And children, you know that in this type of motion, okay, the body, when a body is slightly displaced from the mean position, okay, mean position or from equilibrium position, then the body acquire a what? Oscillatory motion. That means it acquire a to and fro motion about a mean position. In such a case, what happen? A body goes to one side of the mean position, okay, or equilibrium position, and return back to the same position, and it again goes to the other side of mean position, from the mean position, and return back to the same position, which means the motion like oscillatory motion is expressed by the motion of simple pendulum. You know, you have learned in details motion of simple pendulum. If the simple pendulum, like the bob of the simple pendulum, is just connected with a string or thread, and when it displaces and keep at one position, so it goes from equilibrium position to this position. This is called mean position. This is called what position? Mean position. So it will displace, okay, from mean position to one side, and again return back to the same mean position, and again the same bob will go to the another end, okay, from the mean position and return back to the same mean position. That means this type of to and fro motion acquired by the bob of the pendulum is one of the good example of what? Simple pendulum. But children, you know that as the body goes to one side of the equilibrium position, definitely it can come back to the same position, and again the same body goes back to the another position, other side of mean position, then again come back to the same position. So under this case, the body acquire a one vibration or one oscillation. So when a body acquire one vibration, start from mean position, goes to one side, come back to mean position, goes to other side, and come back to mean position. One complete vibration. One complete vibration. Starting from here, come back to this end, goes to other side, and come back to this end. So one complete vibration, also called oscillation. Now children, one point you need to keep in this type of motion is that in this particular type of motion, the body remains confined within a well-defined limit. Which means the body will go up to that position only, that maximum limit. And this maximum limit of position is called extreme position. What position? Extreme position. And this is also called what position? Extreme position. That means if a body displaces from mean position to one extreme position, that body is also displaced to the same extreme position on the what side? Other side. That means this motion is always remain confined within a definite limit. So this is the limit that is called extreme position on either side from the what position? Mean position. That's why I told you the example of oscillation motion is called the motion of the pendulum. Okay, and in this motion we can see that the motion is acquired by what motion? To and fro motion, and such type of motion is called oscillatory motion. But other than this, there are other examples of oscillatory motion, just like the motion of the loaded spring. If the spring is connected by the load and if it start oscillating, then if it acquire what? To and fro motion, then such type of motion is called oscillatory motion. Similarly, the motion of the vibration of tuning fork. We know tuning fork, when it vibrate, it also acquire what? Oscillatory motion. Okay, sewing machine, you know sewing machine also acquire what? Oscillatory motion. That means there are many examples of what? Oscillatory motion. But one important statement that you need to keep in mind between the periodic motion and oscillatory motion is all oscillatory motions are periodic motion, because oscillatory motion are the types of periodic motion. But all periodic motion are not oscillatory motion. Just like all alkalis are bases, but all bases are not alkalis. This is the statement that you have learned in chemistry In the same way, all oscillatory motion are periodic motion, but all periodic motion are not oscillatory. So let me just give you one example. The revolution of the earth around the sun, as you know, it is a periodic motion, but you cannot call that as oscillatory motion. Okay, odd neighbor have to and fro motion when it revolves around the sun. Although that motion is a periodic motion, but we cannot call that motion of the earth revolve around the sun as a oscillatory motion. That's why all oscillatory motion are periodic motion, but all periodic motion are not oscillatory. Now in the next YouTube video, we learn one of the important type of oscillation occur by a body, and this oscillation is called harmonic oscillation. And with that harmonic oscillation, we can even define a simple harmonic motion, and that you learn in the next YouTube video.